Okay, guys, this is looking at Chapter 6 practice test and about exponents and exponential functions. The first few problems deal with our exponent properties. So the first one is just a very simple one, x to the fourth times x to the third. If I think about that as 4x's and 3x's, when I put them all together, I will get x to the seventh. Number 2 is a division problem. And so when I think about that, I think about 5x's up on top. And then I think about 1x on bottom. When I cancel out, I'm left with x to the fourth up on top. Y's, I think about 6y's on top and 9y's on the bottom. If I go to cancel things out there, I'm going to be left with 3y's on the bottom. And so I'm left with my answer of x to the fourth divided by x to the third. Number 3, because I have negative exponents, I'm going to start by moving things around. So the 3 doesn't have a negative exponent, it'll stay in the numerator. X to the fifth will stay in the numerator, but y to the third will move to the denominator because it had a negative exponent. Once it moves, it becomes positive. Z to the second stays up top. On the bottom, the 5 will stay on the bottom, the x to the third will stay on the bottom, but the y to the fourth moves up top and the z to the third moves up top. All right, now that I've dealt with the negative exponents, I'm going to deal with simplifying. So starting with whole numbers, this means 3 divided by 5. And since that does not become a nice whole number answer, I'm just going to leave it as 3/5. X's are on top and bottom, so 5 on top, 3 on bottom. I'm going to be left with x squared up top. Y's are the same. I've got 4 on top, 3 on bottom. So when I simplify, I'm going to be left with y to the first, or just a y on top. And finally, the z's, they are all on top. So much like problem number 1, I'm just going to combine those and get z to the fifth. Number 4, I have an exponent on the outside, so that means I apply it everywhere on the inside. So I'm left with 5 to the third power. Since x already has a power of 2, when I apply a new power, I do that by multiplication. So I get x to the power of 6, and finally y to the power of 9. Now, if I wanted to, I could go ahead and simplify 5 to the third power by 5 times 5 times 5. That would be 125 x to the sixth, y to the ninth. All right, moving on. Number 5 is asking us to write a rational exponent. Remember, rational means fraction exponent. And since it's to the fourth root, that means I'm taking it to the 1/4 power. And finally, number 6 is really much like problem number 1. This means I add the exponent, so 1/2 plus 1/4. We have to get a common denominator, so that would be 2/4 plus 1/4, or 3/4. So my final answer is the base of 3 to the 3/4 power. All right, moving on to page 2, it asks us to write our answer in both scientific notation and standard form. So scientific notation, the first thing I'm going to do, shortcut, is multiply 3.5 times 4, and I get an answer of 14. And then because I have the same base, I can take times 10 and add exponents and get to the 10th power. Now, this is not truly finished because remember, in scientific notation, our first number has to be between 1 and 10. So I'm going to move the decimal point to 1.4. But when I do that, that means I also have to change my exponent. So if I think about this as 14 times 10 to the 10th, if I now change my decimal point here, I have to move it an extra spot. So it would be times 10 to the 11th. Now, reading back, this says write the answer in both scientific notation and standard form. So that means I would move that decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and fill all those empty spots with zeros. Number 8, still writing in scientific notation, but a division problem this time. So I start by whole numbers, taking 3.7 divided by 5, and I get 0.74. And then exponents, I subtract. So -4 minus 5 becomes 10 to the -9. Now, again, much like we talked about before, this first number has to be between 1 and 10. So I'm going to adjust that to be 7.4 times 10. And then if I think about this as 0.74, moving it out 9 places, if I move it here, that's an extra place. So now it's times 10 to the negative 10th. All right, number 9 asks me to graph. Because it's a base number that is greater than 1, I know it's going to be a growth. So in my mind, I know it's going to look like this. But to be a little bit more specific, I'm going to go ahead and do a t-chart table to figure out what values I should actually graph. And so looking at the table or the graph that they've given me, I could pick X values of negative 1, 0, 1, 2, 3, 4, 5. I could even go 6 and 7. I may not need to do all of these. I may be able to get the shape without. But what I'm going to do now is replace the X with each of those values. So I'm going to have 3 to the negative first, 3 to the 0, 3 to the first, 3 to the second, 3 to the third, 3 to the fourth, 3 to the fifth, and 3 to the sixth. And using my calculator, I find out that I have 1/3, 1, 3, 9, 27, 81, 243, and then I would have 729, which is too large for my graph. So now I'm going to go plot these points. So when X is negative 1, Y is 1/3, basically right there on the axis, or on the x-axis. When X is 0, Y is 1, still looks like it's about on the x-axis. When X is 1, Y is 3, so over 1 up 3, that's still pretty much right there on the x-axis. 2, 9, still looking pretty close on the x-axis. Finally, when I get to 3, I'm up to 27. You can start to see it raise up off of that point. 4 is at 81, so just under 100 here. Keep pulling up this. 5 is at 243, so 5, 243. And then 6 is off of our graph. But knowing that this is supposed to be that curve shape, I see it start to form there. And then 10 is asking us to write the exponential function. That's y equals a times b to the x power. Remember, a stands for our initial value. And so in this case, that's where x equals 0, so 27. And then b stands for the common multiplier. Well, in this case, I'm dividing by 3 each time, but my formula doesn't give me an option to divide by 3, so I have to remember division by 3 is the same as multiplication by 1/3. So my formula would be y equals 27 times 1/3 to the x power. Number 11 is asking us to write the explicit formula for the following sequences. So the first thing I have to do is determine what kind of sequence it is. Is it an arithmetic where I'm adding or subtracting, or is it a geometric where I'm multiplying or dividing? So the first one I look at, I see +3, +3, +3. Okay, addition means it's an arithmetic. So the sequence I'm looking at is a sub n equals a sub n, or a sub 1 plus n minus 1 times d. Remembering I need to fill in the a sub 1 and the d. I fill that in with a sub 1 is 4 because that's the first term of the sequence. And then the d is the common difference. In this case, we said we were adding 3 each time, so I would multiply by 3. The second one here looks like if I look at subtraction first, well, it looks like I'm subtracting 6 here, but over here I'm subtracting much more than 6. So subtraction is not my pattern. It looks like instead I'm dividing by 3, much like problem 10 that we just looked at. So geometric, which means I'm using the form g sub n equals g sub 1 times r to the n minus 1 power. Again, I'm filling in the g sub 1 and the r, g sub 1 being the first term, 81, and r being the common difference. Now, again, this is a multiplication, so that means I need to change it to a 1/3 power since I'm actually dividing by 3. All right, 12 says the population of a town is 12,000 and it grows at a rate of 5% per year. Because I see that word grows, I know we're using exponential growth, which is y equals a times 1 plus r to the x power. Just like the problems we did, a stands for where we begin. So the initial value is 12,000. 1 plus R stands for the rate, 5%. But remember, when we write percents, we have to write them as decimals. And then we're looking at 4 years. Plugging that into my calculator, I get an answer of 14586.075. But because we're talking about population, I would round to the nearest whole number, which would be C, about 14,586 people. Number 13 says Leo invests $2,000 at an interest rate of 4% compounded quarterly. How much is the investment worth at the end of 3 years? I see a couple of keywords. I see interest, I see compounded quarterly, and I'm talking about money. So I know I'm using that specific formula for compound interest. A equals P times 1 plus R over N to the NT power. But much like the last one, it starts the same. I'm starting with a principal amount of $2,000, 1 plus the rate, 4%, but putting it in as a decimal, 0.04, divided by compounding quarterly means 4 times per year. And as soon as I put that 4 in there, it also comes up here as part of my exponent. And I'm talking about 3 years, so 4 times 3. Now remember, we have to help our calculator out a little bit, so we're going to simplify the parentheses and get 2,000 times, and then type in 1 plus 0.04 divided by 4, and we end up with 1.01. And then simplify our exponent, 4 times 3 to the 12th power. And then plugging that in, we get 2253.65 when we round to the nearest cent. So that would be answer choice B. Finally, number 14 says the population of a town is 20,000 and it's decreasing. So that tells me I'm using my decrease or decay formula. A times 1 minus R to the X power. In this case, I'm starting with 20,000 people. I'm subtracting 9%, so 0.9. But unfortunately, on this one, they don't tell me a year. I'm going to have to figure out what the year is that gets me to less than 13,000 people. Well, because this is a multiple choice, I know the 3 or 4 problems that I'm going to try. So I'm going to start by replacing that X with a 3, plugging that into my calculator, and I get 15071. That's not less than 13,000, so it must not be 3. So now I'll try 4 years. And when I do that, I get 13715, so 13,715 people. Still not less than 13,000, so it must not be 4. I try 5. When I do that, I get 12,481 people. That's fewer than 13,000. So 5 would be my best choice. All right, on 15, it says there are 1,200 bacteria in a lab dish and the population decreases 10% per day. Compare the decrease with the population for days 1 to 3 with the decrease for days 4 to 6. Guys, we don't need to go real specific with this. Just think about it like this. If it's a decay problem, that means it's this kind of shape. Days 1 to 3 would be like here to here. I'm decaying quite a bit there. Whereas days 4 to 6, not quite as much. The slope is steeper in the first part than it is in the second part. So the population decreases more quickly from day 1 to 3 than it does from 4 to 7. Now it's the same rate the whole time, but because the numbers are less, we are decreasing fewer numbers. All right, our last 2 deal with our transformations. So it says, how does the graph g of x equals 2 to the x minus 3 differ from f of x equals 2 to the x? So the -3 is what's different. If you'll remember, when we subtract a number at the end, that tells me whether I'm going up or down. And because it's a subtraction problem, this one is moving down 3 units. 17 is very similar, except this time the difference happens up here in the exponent. And when it's trapped in the exponent, that's telling us whether I'm moving right or left. But the tricky thing about this one is that when it's moving right and left, it goes the opposite way we think. So since it's a -4, it's actually moving to the right 4. And so we would say C. It is moving to the right 4 units. Guys, that takes us to the end of the practice test. I hope that's helped. Make sure you're doing the practice. Remember, you have the extra review that you can do on Google Classroom as well. And if you've got questions beyond what you've seen here, make sure you're checking in with Mr. Jordan or myself, and we'd be happy to help you prepare so you can do well on this test. Thanks.